Hello and welcome to SI Imaging. In today's tutorial on Aura software, we are going to demonstrate some of the essential analytical features of Aura that will allow you to quantify and characterize optical image data in images that you have already acquired. Now, what we're looking at here is the homepage for the analytical version of Aura. And for any of you who have recently taken images on your AMI HTX or LogOX systems, you'll note that there is no acquisition ribbon here along the base of the homepage. Now that's absolutely fine because all we're doing here today is image analysis, so that feature is not needed. Now, one of the neat aspects of the analytical version of the Aura software platform is that it's available for free. You can download it off of our webpage, as many copies as you may need, onto your laptop, and do your image analyses wherever and whenever you may need. All right, so let's start off by loading several previously acquired images. Now in Aura, you do this by going to File and selecting on either Image Manager or Load Images. If you select Load Images, this is a direct way of accessing individual AMI files, and you can load up as many as you want by pressing Shift, left mouse, and loading up the images in this fashion. And then you're off to the races as far as starting your analyses on these images. Now, I'd like to point out here that with Image Manager, there are several additional features to the information that you have on the files that you're going to be opening. First of all, on the left-hand window, you see the organization of the folders on the driver that were last accessed when opening up Aura. And let's say that we're interested in opening up this particular folder. Hit search, that shows you the files within this folder. And this middle window is a very nice organizational tool in that it breaks down all the metadata, all the camera settings associated with the files in the folder that you've selected. And if you're, let's say, particularly interested in looking at 4x4 binned images, you can go to Binning, select 4x4, and it will show you just the files that have 4x4 bin. Hit Load Selected, and then those are the images that are going to be presented. Let's say on second thought that you wanted to get the 2x2 binned images as well. Well, just go back up to File, Image Manager, and now select the 2x2 binned image selector, and you'll see the individual file that had 2x2 bin as a binning setting when acquired. And now you can do, instead of load selected, you can add to the existing images that are already on the Aura homepage and hit Add Selected. So this gives you now the full set of images that you may want to analyze. So a brief word of introduction on the optical data here before we start our analysis of it. What we have is a set of 5 mice, 1 control mouse, 4 test mice, in which the 4 test mice were challenged 24 hours prior to imaging with a near-infrared fluorophore probe known as OsteoSense 750. OsteoSense 750 is a probe that's designed to specifically bind to hydroxyapatite crystal that is deposited at the growth plate of bones, particularly at the growth plate of long bones in mice. And what we can see here in the 3 different orientation images is the various different foci at which hypoxyapatite crystal deposition has taken place, as indicated by the OsteoSense 750 probe. Now let's proceed with an analysis of the optical signal data in these images. What we are going to do can be briefly summarized as follows. First, we will draw regions of interest, or ROIs, around the signal data on a whole mouse basis. This will allow us to quantify the total signal detected per mouse, and the units of this ROI data will be in terms of total flux, or total photons per second. Then we will show how this data can be presented in a summary table format and exported as a CSV file for further analyses and graph production. Of course, the images themselves of these image files here can be exported in a variety of file formats, including JPEG and PNG, and we will show you how to do this as well. Next, we will summarize how to make and apply background ROIs to your test ROIs in those rare instances where you may need to correct for any significant background signal. Then we will show you how to draw ROI templates that can be saved and applied to multiple other images and avoid the need of redrawing sets of ROIs. And finally, we will show you how you can save AMI image files along with newly drawn ROIs. This feature will allow you to retrieve your ROI analyses and to modify or add to them as needed. Please note that this last feature of saving newly drawn ROIs was introduced relatively recently in Aura version 3.2.0. If the version of Aura that you happen to have on your laptop is older than that, go to our webpage, spectralinvivo.com, and download the latest analytical version of Aura. All right, so let's begin our analysis of this optical data set. We're going to start off with the image here to the left, and we are going, as noted, to draw whole mouse ROIs to quantify the total optical signal detected on a per mouse basis. Now, to draw these ROIs, it's easier if you expand the image. So the easy way to do that is to double click on the image, and it expands to the full height of the analytical window. Now, to draw ROIs, simply go over to Toolbox and down to Measure, and you'll see that there are a variety of options for how one can draw the ROI, either as a rectangle ROI, circle or ellipse ROI, freehand ROI, or as a grid ROI. And this is obviously appropriate when you're doing 96-well plate in vitro analyses as an example. So for our purposes here, we're going to do the whole mouse ROI, and that will be most readily done by going and doing the rectangle ROI. So we activate that, and you can see the blue font for that feature. And I'm going to pull aside the calibration bar so it doesn't visually impede with our ROI drawing. And you can see the crosshairs now of the ROI drawing feature, and you simply left mouse depress and drag and release. And there you have your first ROI with the total photons per second value for the region within the ROI. Now, I'm going to slightly resize this ROI, and any kind of modification of an ROI requires it to get into an active state. So you activate your ROI by double left mouse clicking, and you can see these small squares that are now present at the vertices of the ROI. That means that it's live, and I'm just simply going to go ahead and drag this a little bit that way. All right, now we're going to go ahead and copy paste this ROI across and capture the data from the test mice. So what you do now is, again, it's in an active state, so you right mouse click, copy outside of the ROI, paste ROI, and just repeat that. Okay, and now let's just go ahead and select the second ROI and drag it into place. So that just involves a double left mouse click, it's active, and drag. And we can repeat this for all of the ROIs. All right, and you can fine tune this to get all the ROIs into exact position to capture all of the signal from any one mouse. So I'm going to modify the position of this particular ROI a bit. Fine. So now what we have is the whole mouse ROIs drawn for the control mouse and the 4 test mice. All right, so now to get a visual summary of the ROI data that we just generated here, you can go to Toolbox and then to Measurement Manager and select this icon that looks like a ruler. And what you'll see is the Measurement Manager window will open up, and you get a summary of the individual ROIs and their total emissions, as I said, in terms of total photons per second. And you also get a bunch of metadata details with regard to each image acquired, along with some additional quantifications of signal as max radians, mean radians, min radians. You can add to this by going to edit columns and selecting whatever additional parameters would be of interest. Let's say date and binning, and accept that, and that would then get added to the overall data set of the Measurement Manager presentation. This can get exported as a CSV file. Okay, so you can basically save it to where you will, save it with the CSV extension, open it up in your software of choice, and save it appropriately and do additional analyses and graphs, etc. All right, now the image itself, of course, with your ROI analysis presentation can be saved by simply going to File and doing Save Graphics. And you can then select your storage area of choice. We can do an example here of just call it ROI analysis. You can save it as a JPEG. There are choices. Hit save, and just to demonstrate this, we can minimize the window, go to the folder where the image was saved, and there we are. Okay, so this would be the image that you could then import into any kind of presentation for the purposes of explaining your ROI analysis. All right, so let's get back to Aura. And what we're going to do now is demonstrate how one can apply a background ROI to test ROIs of interest. And in this particular case, we're going to use the control mouse as our background ROI. So to do that, simply right mouse click, and you'll see that you have the option to make background ROI. So we'll do that. And we'll apply it not just to ROI 2, 3, 4, or 5, but to the entire group. And so that's already been pre-selected by default, and you hit accept. All right, so a couple of things to make note of. First of all, the font, if you will, of the background ROI is distinct from the test ROI in that it has a dashed perimeter, and it will also have a B underscore in the name of the ROI. And if you're to go to Measurement Manager now and look at the summary of ROIs, you'll note that the background ROI has a black fill font, so to distinguish it from the other test ROIs. And there you are. That is the creation of background ROI and the automatic application of its value by subtraction to the test ROIs. All right. So what we're going to do here is demonstrate how you can save a set of newly drawn ROIs as a template and then reapply that template to other images where appropriate. This will obviously save you the process of redrawing ROI sets. Okay, so how do we do this? Well, let's go up to Measure and select Save ROIs to File. We'll obviously go ahead and use the ROIs that we've drawn here in Image 1. Click Continue and give it a name. We'll just call it ROI Demo Set and hit OK. All right, so now let's go back up to the other images that are already opened in Aura, and you can do that by going and selecting the minimum icon here on the sliding bar, and this will get you back to this will zoom out to all the other images that are loaded. And we're going to want to go ahead and apply this ROI set to the other two images. So we need to select these images, and you can do that by hitting Select All. All right, you can see the select destination as being given in the top left corner here with the green triangle. All right, so now we go to Measure and Restore ROIs from File. Okay, and we're going to go ahead and restore the 5 mouse, the ROI that was called ROI Demo Set, and we apply it to all of them, and we'll just hit restore ROI. Actually, we can go and restore only to the selected images, and that we selected all of them, it shall apply to all of them. And we've already have it on one, so we can get rid of that and hit continue. And so there you are. You've created an ROI template and then applied it to other images as appropriate. And you haven't needed to redraw the ROIs. They're there and ready to be analyzed. Now we're going to go ahead and save these newly drawn or applied ROI templates to their respective AMI files. The advantage here is that when you reopen the AMI file, you won't have to redraw any individual ROIs or apply sets of ROI templates. The ROIs will already be there, and you'll have the opportunity to either confirm, modify, or add to the ROI analysis done. All right, so how does one do this? You simply go up to File, select Save Experiment, and we can go ahead and name this. And you'll note here that this is now not going to be a .ami file, but in that it has the ROIs superimposed on it, they will be .aura files. All right, so that essentially is done. To go ahead and demonstrate this, we'll go ahead and clear the field. And load the files. So go to File, Load Experiment. And what you'll see is the entire set of AMI files with their saved ROIs brought back, and you are now ready to go ahead and do any additional ROI analyses that you see fit. So the next two protocols for image analysis are really fine-tuning in nature. With the first, we're going to review how to apply metadata parameter values to the image of the aura file. Let's say camera exposure time, binning, anything that you may want to remember about how the image was acquired. The second protocol will go through how to set the min and max of the calibration bar so that it optimally presents the threshold to max data in your image. Now, there will be occasions where you want to have some of the camera settings that were used to acquire an AMI file printed on it to distinguish it from other AMI files that you may have open up in Aura. There's a very easy way to do this. Let's go ahead by way of an example and double click on the left mouse image. What you're going to see in the bottom left hand corner is a green triangle. Select that and you'll have access to all the meta parameters associated with the acquisition of this particular AMI file. And for the demonstration of the use of this feature, I'm just going to select the excitation wavelength used and the emission filter wavelength used. Click OK, and what you'll see is the presentation of both of these parameters in the bottom left-hand corner. What we are going to do here is optimize the presentation of the calibration bar in your images. Now, what you can see is that right now, by default, the calibration bar captures the max and will go to 0 as a default minimum, when in fact the threshold data that's presented in your image is above 0. So we're simply going to go ahead, take the threshold value and apply it to the minimum of the calibration bar. So the entire range of the calibration bar is nicely used in defining the presented data. So to find the threshold, simply go over to the display features, and you'll note that we have both the color range min and max of the calibration bar, and we also have the color range threshold. So simply take the threshold value and have that be now the color range minimum of your calibration bar. And you can do that by simply typing it in. And what you'll get now is the threshold value of data presented as the minimum of your calibration bar, and you also already have the maximum in the calibration bar, capturing the entire dynamic range of the image presented in your IMI file.